Rajeshwari MJ. She pursued her BE in Electrical and Electronics at the People's Education Society College of Engineering, Mandya. She pursued her MTech in VLSI Design and Embedded Systems at the Sri Jagadguru Balagangadharanta Institute of Technology, Bangalore. Her personal skills lie in good verbal and written communication skills. Her areas of interest lie in OOPS with C++, renewable energy sources, HVDC transmission, digital relays, automotive electronics, advances in VLSI design. She has also had papers presented at the national level, such as the Innovative Architecture for SoC Multi-Core Hybrid Processor, presented at the RNSIT, Bangalore.
Welcome to UGC lecture series of BSc Applied Electronics. Today we are dealing with the subject Television and Engineering. Let's start with the Unit 1, Lecture 2, and the topics that we are going to discuss in Unit 1 are sound transmission, picture reception, sound reception, synchronization, receiver controls, image continuity. In the scanning, we are going to discuss only horizontal scanning at this session. In the next session, we are going to discuss about the vertical scanning also. Let us start with the sound transmission. In the previous session, we come across the picture transmission, how the picture is transmitted from a camera tube, how it is converted into video signal, that is the electrical signal, and how this electrical signal is transmitted through the all processing blocks, and finally how it is transmitted through as an electromagnetic wave. This is a brief explanation of picture transmission, but now we are going to study about sound transmission. We know that along with the picture there will be sound information also present. So, there should be a block which going to differentiate sound and also the picture. So, the microphone will going to receive the sound signal, isn't it? And this sound signal converts the sound associated, the microphone going to convert the associated sound in proportionately into the some voltage, into some all this sound will be going to proportionately are going to convert into some of the voltage variations, because in sound signal there will be variations, all these variations are proportionately converted into some of the voltage, and this again this signal will be in a time function, so that we can easily transmit it through a single channel. So, it has single value time function, so that we can transmit this in a single channel, and again this will be said when it is made as a time function, then it can be easily amplituded. When amplituded, after that we can frequency modulated using assign some carrier frequency will be there for transmission. So, through the carrier signal it can be modulated and combined with the AM picture, that is the picture signal. There is a combining network for sound as well as picture signal. This amplitude modulated and frequency modulated, both the signals of picture and sound respectively are combined, and this will be fed to a common antenna, and it is transmitted as electromagnetic waves. Next, come to know about picture transmission and the sound transmission. So, it is easier for us now to discuss about television transmitter. The combination or combining the picture transmission and sound transmission will be a television transmitter. This will be having a blocks like this. Here the light will be focused by that is what the camera tube. Camera tube will be going to focus a light that falls an object that to be captured from the television camera. The output will be the video signal that we discussed in the very first session when we are going to discuss about TV camera. So, the video signal is fed to video amplifier, where the video signal is amplified. The amplified signal is fed to AM modulating amplifier. In between television camera and AM modulating amplifier, there is scanning and synchronizing circuits. This scanning and synchronizing circuit will going to scan each frame in a proper way, and this synchronization circuit, there is a synchronization should be there for each scanning, that is that what picture has to be captured should be transmitted, and that transmitted picture has to be appeared same in the receiver part. So, this synchronizing circuit will come into picture to sync what we captured, that is it should not miss each and it should not even a single details of a picture. So, this will be discussed very clearly in the next slides. This will be fed, that is there is a synchronizing pulse will be generated, and this will also send along with this AM modulating amplifier. There will be a signal coming up from the AM modulating amplifier will be fed to a power amplifier, and this will be sent to a combining network where the picture information is combined with the sound FM signal. The microphone here receive the sound signal and it will be amplified, and with a suitable carrier signal it is modulated, that is frequency modulated, and this FM sound is transmitted, and this will be combined in the combined network transmitted through the common antenna as an electromagnetic wave. This is how the television transmitter works. Next is picture reception, means the commonly picture, how we receive a picture, what are the works, what are the things that will going to work in a background while we are going to receive a picture. That is receiver in the sense commonly the TV, the television, what we call TV, that is in the receiving part, that will going to receive the picture. So, receiving antenna intercepts the radiated picture and sound carrier signals. This is having integrated signal, that is sound and also the picture signal will be received by a receiving antenna, that will be fed to a radio frequency tuner. The very first thing is it is fed to a radio frequency tuner, because we have set for some tuner is tuned for some preset frequencies. So, it only catches frequency in between that range. So, it will capture the information within the frequency range. The receiver is of heterodyne type, that is it employs 2 or 3 stages of intermediate frequency amplification, that is IF amplification will be there in a receiver part, because it has lot of information, the like synchronizing pulses also will be there, sound pulses where sound signal will be there, picture will be there, and all will be having different variations. So, there are different stages of intermediate frequency amplifications will be employed, and all these will be demodulated. In picture transmission what we did, modulation will be done, but in picture reception we need to demodulate, and because after demodulated only we will get the video signal separately. So, we will get video signal, and this video signal is amplified and coupled to picture tube, that is our CRT, the screen, the television. All this will be as a video signal we get separately, and this will be fed to the CRT to get a picture of a picture obtained from the transmitter part. The CRT which converts the electrical signal that obtained from the amplified part, which will going to be into a picture element on the screen. Next is a picture tube. How does a picture tube looks means, it consists of a phosphorus coating screen. The screen is of phosphorus coating, and this part is called as anode. This is focusing anode. This is the most important part, is the control grid, where the voltage everything going to be varied, and this will going to control the beam, and this is a cathode part. From here we are going to fed the video signals. The cathode part, the voltage will come and the control grid going to establish an electron beam according to the variation of voltage. So, due to the variation of voltage there is a beam will be produced. This beam will be going to deflect due to the deflection of coils. The coils will be moving again from top to bottom, left to right, so that it can easily and it can entirely cover all the scenes of a picture. Entire scenes of a picture can be covered through deflection of a coils. Though the deflection coils is again depends on the voltage variations. Due to the voltage variation only, this deflection coils will going to deflect accordingly, and the picture will be fall on the screen. video signal is fed to the grid or cathode of the picture tube when the varying signal voltage makes the control grid less negative. Whenever the control grid have less negative means there is a spot on screen of brighter spot on screen will be appeared. So, for less negative brighter spot can be observed on the screen. For more negative, if it is more negative, then there is a dark spot will be appeared on the screen. And now we move on to sound reception. Sound signals are separated from the picture signals in the video detector block. From the video detector block section, what we get is separated video signal and separated audio signal. This audio or sound signal is taken and it is amplified again and demodulated, and again it is fed to the audio amplifier and it is fed to the final loudspeaker so that we can able to hear the sound. Now we can study easily the television receiver, because we come to know about the picture reception and also sound reception, how the picture is received and how the sound is received. So, television receiver will be having the first thing is receiver antenna, where it is having integrated sound and video signal. It is fed to the RF tuner. Then this signal is set to common intermediate frequency amplifiers, and there will be a video detector block where we can easily separate the video signals, and this video signal is sent to the video amplifier, and also this video signal is sent to the scanning and synchronizing circuit, because the video signal that is transmitted from the transmitter will also have the some signal called synchronizing pulses. Okay, this will be helpful in synchronizing the frames or synchronizing the details of each picture. So, finally, the video signal is fed to the picture tube. So, the synchronizing circuit will be helpful through in a retrace form. When it is come to the original position, when it is moved from left to right or top to bottom, there will be trace and retrace will be there. During the retrace only, there is a synchronizing circuit which will trigger the synchronized pulse to synchronize the exact picture that will be coordinated in both receiver and as well as transmitter. Now, come to the sound. Here we separated video signal and sound signal. The sound signal is fed to the sound IF amplifier, and again it is demodulated and audio amplified and it is fed to the loudspeaker. This is how television receiver works. Next, the important thing that is I already discussed about synchronizing circuit, synchronizing bulk. This synchronization helps in coordinating the scanned pictures. So, what we scanned in the transmitted part should be same in the receiver end also. That is what at both the instant what we scanned in the camera tube, that should be same in the picture tube also. That will be so this synchronization is essential to maintain the same coordinates of scanned information in camera tube and as well as picture tube. Otherwise, what happened, we will get the picture of a spoiled picture or merged picture like that. So, to ensure perfect synchronization between the scene being televised and picture produced on the raster, synchronizing pulses are transmitted during the retrace. That is what in retrace this will be useful. The synchronization part come to picture in retrace period, that is flyback intervals of horizontal and vertical motion of the camera scanning. In a scanning part, we know that there is a trace and retrace, that is flyback interval. Retrace is also called flyback intervals. There this synchronizing pulses come to picture. Thus, in addition to carrying picture details, the radiated signal at the transmitter also contains synchronizing pulses. As I said, the transmitted signals also contains synchronization pulses also along with the picture details. If there is no synchronization, what will be the effect? The picture easily we can recognize there is no synchronization between picture A and B due to the lack of synchronization. This is the effect of synchronization. So, original picture will be A. Due to the lack of vertical synchronization, the picture is splitted. We got a split picture. So, to ensure synchronization between transmitter and a receiver, we know that there should be a synchronization pulses are used to start sawtooth signal. Separate sync pulses are required for both horizontal and as well as vertical scanning. So, here vertical we call V sync pulses and for horizontal we call as H sync pulses. For horizontal scanning, the sync pulse appears every 64 microsecond, that is its frequency of occurrence is 15,625 pulses per second. Okay. For vertical scanning, sync pulse, that is V sync, appears every 20 millisecond, thus its frequency is 50 hertz. This is a simple example, that is we can consider how the H sync pulses and V sync will be helpful for synchronization. Next, the important topic is receiver controls. We saw nowadays in a TV remote control itself we can control all these features, but in olden days all these receiver controls will be on a TV panel, that is TV front panel itself, all these knobs will be there. Some of the receiver controls are channel selector, fine tuning, brightness, contrast, horizontal hold, volume controls. Some receivers also provide tone controls also. So, what does the channel selector does? This is very important to tune for a particular channel. There will be plenty, millions of channels are available nowadays. But we need to watch only particular channel, right? So, to watch a particular channel, the very first thing we need to do is select the channel using a channel selector. Is used for selecting the desired channel. Next, fine tuning control is provided for obtaining best picture details in the selected channel. Fine tuning means we are going to tune it finely, that is even the fine or tiny details should be properly visible. That is why we are going to fine tune the controller to get a proper visibility of a picture. Next is brightness control, where is the beam intensity of the picture tube and is set for optimum average brightness of the picture. So, this will going to helpful in a contrast, like a brightness will be improved, so that the intensity of a picture tube also will be increased by controlling the brightness control. So, the contrast control has actually gained control of the video amplifier. When we are going to use the contrast control, the gain control of the video amplifier will be directly affected. Next will be and this contrast control will be varied to obtain desired contrast between white and black contents of the reproduced picture. So, all with these things we are talking about the olden days only, these all things will be of monochrome or white and black TV. The hold control is used to get a steady picture in case it rolls up or down. In olden days it was very difficult to get a picture clearly because of lack of technology, but nowadays it is not like that. That is why there was a hold controller in the receiver controls front panel. So, this hold control will what does it done? It won't allow for a picture to roll back, or it won't allow the picture to move up and down. Next is the volume and tone controls form part of the audio amplifier. So, the volume control and tone controller is used to get a good quality of a sound signal. This will be a part of audio amplifier. Next, in color receiver there is an additional control called, that is saturation control. It is used to vary the intensity or amount of colors in the reproduced picture, but in monochrome or black and white there is no color. So, there is no word of this color or saturation, but in color television we need to change the intensity of colors according to our eye visibility or clarity that we needed. So, this color or saturation control will be used to vary the amount or intensity of colors. The whole control is used to get a steady picture, and again we are going to use this volume control for to hear a sound signal properly, and that will be directly connected to the audio amplifier. In modern color receiver that employs integrated circuits in most section of the receiver, the whole control is not necessary and hence usually not provided. So, here this is how the television receiver control looks, and this is how the front panel. In the front panel all these control knobs will be there, like vertical hold, channel selector, fine tuning, contrast, brightness, volume and on and off, tone. Next important topic is image continuity. While televising picture elements of the frame by means of scanning process, it is necessary to present the picture to the eye in such a way that there is a illusion of continuity, so that we can easily view a picture in a continuous manner. That is what the technique that we are going to use is persistence of vision. Because of persistence of vision, that we are able to see a picture as an illusion of continuity, even though it is not continuous. Because of persistence of vision, we are able to see it as a continuous picture. That is because of the persistence of vision. The sensation produced when nerves of the eye's retina are stimulated by incident light does not cease immediately. That is what? Because whenever we are able to see anything, that will persist till 60 milliseconds or 1/60th of the second. So, in between that, if any picture in lesser than 60 millisecond if it comes, we will assume that it has a merged image. So, that our eye will be in a illusion of a continuous picture. In present day motion picture, 24 or 25 still pictures of the scene are taken per second. This is what usually they are going to use. 24 or 25 still picture of the scene are taken per second. This much of frames will be moved and later projected on the screen at the same rate. This will be projected at the same rate. Image continuity can be achieved through scanning only. All this image continuity will be achieved. Next, the important topic, that is scanning. Till now we use this word scanning all over, but we do not know exactly what the scanning will be. Scanning is a process of extracting signals pertaining to the individual elements of a picture. It will going to extract the signals of a individual elements of a picture in a quick succession, one after the other. So, values of light in a scene are functions of space here. Scanning of the charge image converts the charges on the surface of the target into electrical signal varying in time frame called video signal. So, from scanning we got a video signal, that is scanning the charge image converts, that is the charge image will going to convert that into a electrical signal, and this electrical signal will be of varying time or time function. So, this signal is called as video signal. Why do we need scanning? To transmit all variations of light present in the space of a picture at a single instant of time. Otherwise, without scanning we need plenty of channels because there is lot of variations, but due to scanning everything will be converted to in a function of time and it will be transmitted in a single channel. It is not feasible to use many channels, that is what, it is not feasible for us. That is why we are it is very needed, scanning is needed. So, already I said there is a sawtooth current for scanning purpose. So, scanning purpose will be done with the help of sawtooth current. Horizontal and vertical scanning of the charge image in the camera tube and the phosphorus on the fluorescent screen of the picture tube is accomplished by deflecting a well focused spot of the electron beam horizontally from left to right and vertically from top to bottom. Horizontal deflection is fast. It takes 64 microseconds for one scanning line. Always the horizontal deflection is fast, that is it only takes 64 microseconds, but vertical will be slower compared to horizontal deflection. This is the trace period what we called in the scanning what we study, and this is a retrace or flyback period. The current across time of a horizontal deflection. This is the trace period, linear ramp, and this is the retrace period. The vertical deflection is slow and it is 20,000 microsecond or 20 millisecond. This is how it is very long, very slow. So, this is having a 20 milliseconds and this is how it is vary with the function of time. The linear rise of current in the horizontal deflection coil deflects the beam across the screen with a continuous and uniform motion for the trace from left to right. Horizontal in the sense it is always scan the elements of a picture from in the manner of left to right in a continuous and uniform form. At the peak of every rise, of a sawtooth, it will come back to the flyback position rapidly decreasing to the initial value. So, This fast reversal produces the retrace or flyback, that is called as retrace. This is how the starting line, when it is started here of scanning from left to right, it ends here, and again the retrace, the dotted line will indicate the retrace. During retrace it again come to its initial value, again starts from left to right. Similar things will continuously happen till it continues single frame. Horizontal scanning will be having like this: first line, second line. This is trace, retrace period, trace, retrace period, and this is the raster, the screen. If it is a raster of 625 lines, if this is one line, like that 2 line, every trace will be 1 line, 2 line, like that 625 lines should be traced. So, in each lines the same tracing and retracing will be done. This is how the 620 lines will be traced in a horizontal scanning. So, now we come to an end of the session. So, what we discussed, the summary of the session is sound transmission. The sound transmission, what we discuss in the sound transmission, the microphone converts the sound associated with the picture into proportional voltage. Microphone will going to convert the sound associated picture into a proportional voltage. Sound is frequency modulated and picture is amplitude modulated and outputted through the same, both sound and picture will be outputted through the same antenna. And to ensure perfect synchronization between the scene being televised, so in synchronization what we discussed, we need a sync pulse to synchronize between what we televised and what we received, what we televised and what we transmitted. And also in image continuity, the main theme of the image continuity is the persistence of vision, that what naturally available for our eye is taken as an advantage of a image continuity. Then the last part is scanning. Scanning is process of extracting the signals pertaining to the individual elements of a picture. This is most important, the scanning part. Otherwise, if there is no scanning, means there should be a plenty of channel to send all the information of a picture. So, some of the questions regarding this session are: why is scanning necessary in TV transmission? Why is it carried out at a fast rate? How the synchronization between transmitter and receiver is maintained? What is the need of scanning? Explain the horizontal scanning process in TV system. Finally, the references are newagepublishers.com, Basic Television Principle and Servicing, Bernard Grob, McGraw-Hill publication, Television and Video Engineering book, AM, Dhake, Tata, McGraw-Hill publication and Co. This ends the session. Thank you.